Here's what you need to remember about logarithms. Logarithms are always exponents. They always equal exponents. So what we're going to do is we're going to take an exponential expression and we're going to write it in logarithmic form. Okay? And it sounds worse than what it is really. So let's say that I have 3 to the x. Actually, let's not use a variable yet. Let's do 3 to the second equals 9. Okay? To set this up in logarithmic form, we do log. Then we use what we call the base. What's the base, do you think, in that expression? 3. So it goes really little as the base here. Log base 3 of 9 equals, and it always equals the exponent. Okay? So if you have, let's say a to the x equals b, then we have log, what's the base? A of what? Of b. It always equals the exponent. Okay, so the most important thing today, we're going to start practicing going from one form to the other. This is called exponential form. Exponential. This is called logarithmic. I don't have any clever little sunshine trick for this. Here, one side of the chart will be logarithmic form, the other will be exponential form, and we'll switch between them and see what happens. Let's do 10 to the first equals 10. Then let's do, and we can get into some fractions. Base of 1/2 of 32 equals -5. And then let's do all right, so we're going to switch between the forms.
Can I do one?
Sure. I don't know that that's hooked up. I didn't know that that's hooked up here.
Old-fashioned one.
All right, change the first one from logarithmic to exponential.
Oh my God. I did it backwards. I was thinking about something.
That is correct, though. Look at the second one. I'm going to put it in logarithmic form. So it's log. What's the base? 10 of what? Equals
1.
1. It always equals the exponent. How about the next one? What's the base?
Log 1/2.
1/2. To the -5. Now, what does a negative exponent do?
Divide.
It flips it, right? Negative exponents flip it, so that would become 2 to the 5th, and that is 32. So that's a true statement. Are y'all following it? You understand? All right, how about here? How about the last one? Log.
1/4.
Base of 1/4. 4. -1. Pretty easy. All right. If you start to get confused also, this is a little trick. If you have the log written on the left side, when you change the form, you do 3 to the 4th equals 81, and it looks like an E for exponential form.
Not gonna hear that.
Okay, so that's okay. So if you can change forms, you can evaluate. We're not going to use the calculator just yet. What
else do we have to do in that?
Well, logarithms allow us to solve equations where the variable's in the exponent. So we'll talk about it. Looking here at evaluate, let's say I had log base 4 of 64. Evaluate means tell me what it equals. If logs equal exponents, what do I need this to equal to make that true? Think about it. What? 3. 3, correct. It's 3. Your calculator will only do a base of 10 or a base of E. And you are correct, it is 3. Because what do I need to raise 4 to get 64? So think about changing the form. Does that make sense? Yeah. Yeah, same thing. How about this one? Log of, oh, this one's a little bit harder. Log base 5 of 0.2. What is 0.2? That's the question you have to ask yourself. What is 0.2 as a fraction? 0.2 is 2 over 10, which reduces to
1 over 5.
1 over 5. So 5 to the what power would give you 1 over 5? Negative what? Somebody said it first. Yes, negative 1. How about if I asked you log base 7? Oh no, let's switch those up. Let's do log base 49 of 7. Now you got to kind of rewind and think about some things you've learned. I need an exponent on the base. So if the base is 49, what could my exponent be? It's going to make that be 7.
Negative 7.
Why is it a half?
Because
a square root is a half exponent, right? Square root of 49 is the same thing as 49 to the 1/2. So you're absolutely right. I get 1/2. Does that make sense? A little bit? Maybe. Yes, no, maybe. How about log base 8 of 2?
2.
You're close, but I don't want a third. You're exactly right. 8 to the what power gives you 2? It's a third root, which would mean an exponent of 1/3. Does that make sense to everybody?
100%.
All right. So somebody asked about your calculator. Okay, we have two. I don't want to call them common logs because one of them's called a common log. No. You know, in math, every time we're missing something, there's always an imaginary or an implied value, okay? The square root, if there's not a root there, then there's an imaginary 2. If there's no exponent, it's an implied 1 as an exponent. If there's no base, it's an implied 10. No base. And if you think about it, our number system is base 10, right? Right, it is. It is. Yeah. So we put a 10 there if there's not a base, and that's what we call a common log. So if you look on your calculator, you have a log button on your calculator. If you push that, though, it's only going to do log base 10. Now, some of you have a little bit fancier calculators where it's going to let you input a different log, but if it just says, I'm in a different base, excuse me. If you just push log and you don't indicate a base here, it's a base of 10. So if you had log of 100, and let's just use an easy example. Okay, there's no base there, so that means, and I want you to evaluate, 10 to the what power gives you 100? 2, right? So on your calculator, type log 100 and make sure that you get 2 back out when you do that. I told you there's two typical types of logs. One is the common log. The other is what we call a natural log. A natural log is a log that has a base of e. Okay? If you ever see log base e, that's the same thing. We use ln for that. That's not a 1, that's an L. Okay? ln. Yeah.
That's confusing.
So there's an ln button on your calculator. It's a base of e. That's the probably, I know the other one's called common log, but this is the one that's the most applicable in real life. It's a log base of e. This is what the like your Richter scale that measures earthquakes and things. That's based on a logarithmic scale.
Okay, so what does E stand for?
It's that irrational number we talked about.
2.7 something.
There you go.
Oh, yeah.
Yeah.
Okay, got
All right, so we got common log. We got natural log. Let's make sure you can work with both of these. Let's say think about this for just a minute. I want you to evaluate, and I want you to think about it. A natural log is the same thing as what? Log base E. So now if I think about what does this equal, well, if I take E, I need to raise it to some power so that it equals E squared. What's the question mark need to be?
E1.
2. This is a property that I'm actually getting you to derive on your own. Okay? If these are the same, it doesn't matter what they are. If these two things are the same, then all of this just cancels and it gives you the exponent that's here. Okay? So if I had log base 12 of 12 to the third. Actually, did I just use that? No, I used 12. This is going to equal what? 3. What power do I need to raise 12 to get 12 to the third is 3. Okay, does that make sense to everybody? It doesn't matter what these are, but they cancel and they leave you with this. So we might have to do a little bit of manipulation. Let's say this was 64. You could change this 2 to the what power 64?
8, 6, 7, 8.
2, 4, 8, 16, 32. 6. You'll get it eventually. So this would give me 6 because they cancel out. It's just another way to do exponential form. Okay, but if you see it with variables and things like that, know that if the two bases are the same, the base of the log, and then there's an exponent hook there, they cancel out and just leave you with the exponents. This also works the other way. If the base, let's say I have 6 and I raise it to a logarithm with that same base of, let's say, x. All of this will cancel and it will just leave me with x.
So when you're trying to manipulate it, can you just treat log as another number?
No, log's not a number, log's an operation. Right.
So how do you move it around? You split it?
I'm fixing to show you. I'm gonna show you how to apply it now. Yes, exponentiating and logarithms cancel each other out, which is what we're going to use. That's what we're going to do. I told you in the beginning that logarithms were exponents, and we're going to use them to solve equations. For example, if you had something like let's say this, okay? And I asked you to solve. At this point, you wouldn't know the opposite operation to do to get x by itself, right?
Yes.
What?
Divide by 2.
You can't divide by 2. That 2's got exponent hooked to it. So what I'm going to do is change forms, okay? I'm going to change forms to get log base 2 of what? 8 equals x. Now, this is solved for x. So x is 3. You're exactly right.
Wait, so explain. Oh, just because like you find out how many times.
Log of 2 is first and the 2 to the third. How would you say that? Log of 2 to the
Log base 2 of 8 equals x what?
If you change that to 2 of 2 to the third.
So
You
Miss
say
McGee,
log to the 2 to
Log
the
base 2 of 2 to the third.
so Miss McGee, you just see. So pretty much, you just see how many times the bottom number goes in the top row, and that's what the exponent.
No, not how many times it goes into, but what you have to raise it to. The exponent, because logs are
So just
exponents.
find it.
All right, so y'all asked a very good question about what cancels out logs. So let's do it. Let's find the inverse. Remember, inverses mean opposites, right? Find the inverse.
-4x.
Now remember what we do when we find inverses. What do we do first? Switch x and y.
Oh my.
Okay, so now if I switch x and y, I get x equals, and after I switch x and y, what do?
Logarithmic.
Well, I solve for y, but you're right. I'm going to log it. I'm going to change it to logarithmic form. So after I switch x and y, I'm going to solve for y. So I'm going to do log, what's the base? 4 of what? Of x equals y. Is it solve for y now?
Yeah.
Yes. So this and this are inverses of each other. Okay? Opposite operations, logs and exponents. Does that make sense to you? You want to do one more? And I'll be done. That'll be it.
Oh, so we gonna do our homework?
I haven't, I'll give it to you, yes. Let's do one more inverse. Natural log this time of x minus 5. Find the inverse. Find the inverse. Matthew. So the n, this is, remember, this is natural log, so it's the same thing, Ben, as log base e.
Yeah.
So when we find the inverse, the first thing we do is what? Switch the x and the y. So I have x equals log base e.
I just have 15. So I can write that.
You should, because in order to solve this for y, I'm going to have to change forms. And to change forms, I need to know what the base is. So what's the base?
5.
Look at that log. What's the base? E is the base.
Yes.
E is the number that's written really little, okay? E, what's the exponent? Look again, logs always equal exponents. X equals.
Y minus 5.
All I did was change forms. That same log base, b of a equals x, so b to the x equals a. I just changed forms. Is it solved for y yet? No. What do I need to do?
5.
Add 5 to both sides, exactly. I can't combine that with e to the x. They're not like terms. So if I can't do it, I just write it. E to the x plus 5.
So I had
Where did what come from?
Yeah, I had you to you like
Because the natural log has a base of e,
Exactly. Natural log is the same thing as log base e.
and you're changing
So the base is e. Logs always equal exponents. And then this, what's left behind it is what it equals here. So if you want, that's why I was telling you maybe you want the log written on the left side instead of the right. So it's e to the x equals y minus 5. One more? A little bit of confusion there on that one. Let's do one more. Oh, tragic. Are you okay? Let's do the inverse of a logarithmic. Exponential. Let's do y equals. I will tell you that whenever you start, after you switch x and y, you want to make sure that you isolate either the exponential piece or the logarithmic piece. Okay, meaning if something's hooked to it, get it unhooked before you change forms. So to find the inverse, the first thing I do is swap them, switch x and y. I can't log it yet because you see the 3? It's not part of the exponent. Whenever I'm in exponential form, I only want a base in the exponent and that's it. So I need to move it. So now I've got x plus 3 equals 2 to the y. Now change the form.
log 2
Log, the base is 2 of
x plus 3
mhm.
equals y.
Logs always equal exponents. Does that make sense?
Yeah, I got it. I just